Hey there, science enthusiasts. Ever wondered why light reflects? Today, I'm diving into the quantum secret behind this everyday phenomenon. It's not just about bouncing waves, there's a lot more going on at the quantum level. Let's get started. First up, photons and electrons. Light is made up of tiny particles called photons. When a photon hits a surface, like a mirror, it interacts with the electrons on that surface. These electrons are bound within atoms, but can oscillate when they're disturbed by electromagnetic fields, like the field of an incoming photon. Picture this: a photon meets an electron, and a tiny dance begins. Next, we have absorption and re-emission. The surface electrons absorb the photon's energy for a brief moment, then they re-emit a new photon. The direction in which this new photon is re-emitted depends on the structure of the material and the boundary conditions at the surface. It's like the electron takes a short break before sending the photon on its way. Now here's where things get really interesting. Constructive interference. At the macroscopic level, many atoms work together. The re-emitted waves from these atoms interfere with each other. The only directions where the photons interfere constructively, meaning they reinforce each other, are the ones that match the law of reflection. The angle of incidence equals the angle of reflection. It's like a perfect symphony of light waves. And for the grand finale, let's talk about Feynman's path integral view. Physicist Richard Feynman had a cool way to explain this. A photon can take every possible path, from the source to the detector, straight paths, curved paths, even wildly loopy paths. But when you sum up the probability amplitudes for all these paths, the paths that follow the law of reflection dominate because their phases add up coherently. Other paths interfere destructively and cancel out. Imagine a photon exploring every possible route before deciding on the perfect one. So, why does light reflect? At the quantum level, electrons in the material absorb and re-emit photons. The re-emitted photons are most likely to be detected along paths that satisfy the law of reflection due to quantum interference. It's a beautiful dance of particles and waves. If you're curious for more visual analogies or a deeper dive into Feynman's explanation, let me know in the comments below. Thanks for watching, and don't forget to hit that like button and subscribe for more mind-bending science content. See you next time.